The number of significant figures in a number is important because it indicates a degree of precision about a reported number. There are rules that you'll be responsible for knowing about counting the number of significant figures in a number. The first rule is that non-zero digits always count towards the number of significant figures. The number 123 has 3 sig figs because all of the digits are non-zero digits. 2576 also contains only non-zero digits, so all of the digits in this number count towards the number of sig figs. Therefore, there are 4. The number 2.6 contains 2 sig figs because both digits are non-zero digits, so they always count towards the number of sig figs. Zeros count sometimes towards the number of sig figs. There are 3 different classes of zeros that we'll discuss. Leading zeros come before non-zero digits, and they never count towards the number of sig figs. 07 has only 1 sig fig because the 0 that precedes the 7 does not count towards the number of sig figs. This number has 3 sig figs because the 2 zeros in the beginning of the number do not count towards the number of sig figs. This number contains many leading zeros, none of which count towards the number of sig figs, so this number has only 2 sig figs. The second class of zeros are called captive zeros. These are zeros that come between non-zero digits, and they always count towards the number of sig figs. The 0 in this number is caught between 2 2's. Therefore, it always counts because it's a captive 0, and this number has 3 sig figs. The 2 zeros here are trapped between 1 and 9. Therefore, they are captive zeros, and this number contains 4 sig figs. This number has 2 different classes of zeros. All the way on the left, before the decimal point, is a leading 0, so it does not count towards the number of sig figs. However, the 0 between the 3 and the 4 is a captive 0, so it does count. Therefore, this number has 5 sig figs. The third class of zeros are called trailing zeros. They come after non-zero digits, and they count only if the number has a decimal point. This number has 2 trailing zeros. However, the number does not have a decimal point, so it has only 1 sig fig. This number looks quite a bit like the number above. However, there is a difference. It has a decimal point. Therefore, because of the presence of the decimal point, this number has 3 sig figs. This number has 2 trailing zeros. Both of the trailing zeros do count towards the number of sig figs because of the presence of the decimal point. Therefore, this number has 4 sig figs. This number has 2 different classes of zeros. The first 3 zeros in the number are leading zeros, so they never count. The 0 that comes after the 3 is a trailing 0. It does count in this case because the number has a decimal point. So this number has 2 sig figs. Let's try some guided practice counting the number of sig figs. The first thing you want to think about is, are there zeros in the number? If not, the number of digits equals the number of sig figs. If there are zeros in the number, you need to ask yourself if they are leading zeros, which never count, captive zeros, which always count, or trailing zeros, which sometimes count, only if the number has a decimal point. This number contains no zeros, so all of the digits count towards the number of sig figs. Therefore, this number has 3 sig figs. This number has a 0. Because the 0 is trapped between 2 non-zero digits, it's a captive 0 which always counts. Therefore, this number has 4 sig figs. This number also has a 0. Because it comes after all non-zero digits, it's a trailing 0. This trailing 0 does not count because the number does not have a decimal point. Therefore, the number has 4 sig figs. This number contains 2 zeros. These zeros can be classified as leading zeros which never count. Therefore, this number has only 1 sig fig. This number has a number of zeros. However, these zeros are trapped between non-zero digits, so they are captive zeros which always count. Therefore, this number has 6 sig figs. This number contains 2 different types of zeros. The first 0 that comes before the decimal point is a leading 0, so it never counts. The 0 caught between the 9 and the 5 and the other 0 caught between the 5 and the 7 are captive zeros because they are stuck between non-zero digits, so they always count. Therefore, this number has 5 sig figs. This number has 4 captive zeros. We know they're captive zeros because they are stuck between non-zero digits. Therefore, this number has 6 sig figs. This number also has a captive 0. We know it's captive because it's stuck between 2 non-zero digits. Therefore, this number also has 6 sig figs. Here are some problems to practice on your own. You can try these problems and pause the video while you're working. When you're finished, unpause the video and you can check your answers. When we do calculations, it is very important to consider the number of significant figures. When you're doing addition and subtraction, decimal places are important. The answer to an addition or subtraction problem should have the same number of decimal places as the number with the fewest number of decimal places. Let's look at an example. If you were to type 1.45 plus 2.9 into a calculator, you would get 4.35 as the answer. However, we have to evaluate whether the significant figures are correct. Because this is an addition problem, we are worried about decimal places rather than sig figs. 1.45 has 2 decimal places. Keep in mind that decimal places are only the places after the decimal point. 2.9 has 1 decimal place. We want our answer to have the same number of decimal places as the number with the fewest number of decimal places. So since 2.9 has only 1 decimal place, we want our answer to have only 1 decimal place. The answer to this problem is 4.4. Our 1 decimal place is the 3, and we need to look at the next number of 5 to decide what to do with the 3. Should it get rounded up or should it get rounded down? It should get rounded up because the digit that comes after the 3 is a 5, and we always round up when the digit is 5 or greater. So 4.4 is our answer. If we typed this problem into a calculator, we would get the answer that's shown here. Because this is a subtraction problem, we are concerned about decimal places rather than sig figs. The first number has 4 decimal places. The second number has 3 decimal places. Therefore, we would want our answer to have 3 decimal places. So we know our answer will be 33.53 something. Should the something be a 2 or a 3? We need to evaluate the number beyond the 2 to decide whether we should round the 2 down to a 2 or up to a 3. Since the number is a 6, the 2 should get rounded up to a 3. So we should have 33.533. For multiplication and division problems, significant figures are important. The answer to a multiplication and division problem should have the same number of significant figures as the number with the fewest number of significant figures. If we type this problem into the calculator, we get the answer 2.808. 2.34 has 3 significant figures. Remember that we determined this because this number, 2.34, contains 0 non-zero digits, so all of the digits count towards the number of sig figs. 1.2 contains 2 significant figures. Therefore, our answer should have 2 significant figures. So the answer will be either 2.7 should either 2.8 or 2.9. We'll round the number to 2.8 because the 0 that comes after the 8 causes the 8 to get rounded down to an 8 rather than up to a 9. So 2.8 is our answer. If we punch this calculation into the calculator, we get a long decimal as our answer. Because this is a division problem, we want to evaluate the number of significant figures. The first number has 2 significant figures. Remember that the 0 doesn't count because it's a leading 0, and leading zeros never count. The second number has 4 significant figures because all digits are non-zero digits, so they all count towards the number of sig figs. Therefore, our answer should have 2 sig figs. We have to look at the 0.54 and look at the number just beyond the 4. Because it's an 8, the 4 should get rounded up to a 5. So our answer is 0.55.